Guys, so where we can store our logs, or where we can store our our index.html, or the configuration files, the deployment files,
Image, sir.
image or index.html, right?
Yes, sir.
Yesterday something like these are the two containers, right? So these are the two containers are running in one EC2 instance. So right, this is one container and this is one container, right? This is one EC2 instance. What is this,
Sir,
guys?
sir, screen not sharing, sir.
Yeah, are you able to see my screen, right?
Yes, sir.
Yeah. So this is a EC2 instance. What this is? This is a EC2 instance. So in the EC2 instance, what you did, guys, you install the Docker container, right? So install the Docker container. Without a Docker container, without a Docker service, so we cannot run the Docker. Without Docker container, we cannot run the Docker containers. Without Docker service. What is that? Docker.
OS Docker container.
Yeah, Docker service. So this is your EC2 instance. Instance is nothing but a, so OS everything is running, right? So this is a Docker service is running. So Docker service is running on your instance, right? So now this is the container. So this is the web app 20 is the container, the name of the container. So web app 21 is the container. So 21 is the container. You shared you created a directory. You created a directory in the EC2 instance. What it is? Temp share HTML. For example, you created a directory called as a temp share HTML, and you attach it to the, so this is a bounded mounting. This is a bounded mounting. So you are attaching to the a container. What is the document root, a default root path for the nginx? So what is that, guys? USR
User
share
shared
nginx
NGNX HTML.
HTML. So you are mounting these two slash USR slash share slash nginx slash HTML, right? So these are the, so two directories, two containers mounting to the slash tempo share HTML. If one container, if one container crashes, so the application will run on the other container. So for example, these two containers are deleted, guys. So how do you know if that container is running or not? If the container is running or not. So how do you know?
Status. We can check status, sir.
Status. For example, you have a number of containers. For example, 100 containers, sir, running on one EC2 instance, right? So 100 containers are running on one EC2 instance. So you want to run. So how you can check? How you can check if the container crashes, or if the container is shut down, or if the container is stopped state. So how do you know? So for example, if it is a
Yes,
EC2,
actually.
so if it is a EC2 instance, right? So we can use the monitor. So right, we can use the monitoring tool. So monitoring tool calls as a something like a Nagios monitoring tool. So Nagios or Centron or Jabix or CloudWatch. What is that, guys? Cloud. CloudWatch is from the AWS CloudWatch. So we have a number of monitoring tools are there, right? So we can monitor. If something goes wrong, then so it will get the alert. You will get the alert from something like this EC2 instance is in shutdown state, or this EC2 instance is heartbeat failure. But how do you know if the container is running or not? If the container is if the container is running or not? If the container is deleted, if the container container is deleted, So is there any auto healing, guys? No auto healing, right? No auto healing and no auto scaling, no monitoring, so no backup. So these all are the drawbacks. These all are the drawbacks. So if you use as a container, right, guys? So who will monitor or who will manage these Docker containers? Who will manage these Docker containers? So we can use the we can use. So who will monitor? So container orchestration. So container orchestration. Guys, you know, in the music troupe, someone is orchestrate the which instrument need to play on which time. So right, some guy is orchestrator. The music orchestrator will give you the instructions to the musicians. So which instrument will play on the which time, right? The same way, so we need to they need to orchestrate the Docker containers, but there is no auto healing, there is no auto scaling, right? So we need a solution. The solution called as a Docker designed one solution called as a Docker Swarm. So Docker Swarm and the other companies. So Google, who is that, guys? Google created a solution called as a Kubernetes. So what is that, guys? Kubernetes. K8s. K8s means Kubernetes. So why K8s, guys? So before, after K, before S, how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. So that's the reason this is a Kubernetes. Kubernetes is a K8s. So why Kubernetes, guys? So why
For
Kubernetes?
monitoring.
Yeah, for monitoring for orchestration, for monitoring or orchestration the containers. So container orchestration tool is, what is that, guys?
Kubernetes.
Yes, very good. Docker, SAM, and Kubernetes. But most popular orchestration tool is Kubernetes. So nowadays everyone is using Kubernetes. So Docker, SAM having some drawbacks and Kubernetes having some advantages. So that's the reason Kubernetes are using the container orchestration tooling. Guys, now you understood? Yeah. So
Yes, sir.
how you can build the Docker image? Docker image you can build by using the Docker file, right?
Build
Yeah.
Docker
So did
file.
you guys watch the Docker Compose? I gave a task, right, guys? Docker Compose. So what is Docker Compose? Guys, what is Docker Compose? I already gave a task, right, yesterday. So here, so we are running only the
Is used
single
for
container. Sorry?
multi-containers.
Yeah. So Docker Compose is a tool for defining and running a multi-container application. It is a key of unlocking the streamlining and efficient development and deployment experience. So Compose simplifies a control of your entire application stack. So making it easy to manage the services, networks, and volumes in a single, so comprehensible AML configuration. So what is that, guys? So everything will be in the single file. Single YAML file is nothing but a Docker Compose. Docker Compose. So why use Docker Compose? How Compose works? So how to install the Compose? So how to impose the Compose and everything. Who defined this Docker Compose, guys? Docker Compose is defined by the Docker. So Docker Compose. So this is a tutorial aims to introduce a fundamental concept of the Docker Compose by guiding you through the development of a basic Python web application using Flask framework, guys. You see, so not this one. Yeah. So this is the define a service in the compose. So suppose something like a compose.aml. So services, web services, build, ports, redis, image. So we'll create a a compose YAML file. Compose file defines two services, web services and Redis services. Right? Build and run your application with the compose. So it is. So you defined a compose, guys. You defined in the YAML file. You defined in the Docker compose files. The advantage of the Docker compose file is nothing but a Kubernetes files, deployment files. These are the files. You guys can watch it, guys. What is a Docker compose? You will understand. Okay, guys, understood?
Yes, sir.
Second, I want to open the document. Yeah, Kubernetes. Before Kubernetes. Yeah, you know, right? So as of now, what we discussed, so real world applications. So what are the real world application? Monolithic architecture and microservice based architecture. So what is the difference between monolithic and microservice architecture? So nowadays, every application will be deploying as a microservice.
Service.
Microservice. So monolithic means so old approach, everything, your application, entire application. For example, WhatsApp contains status, everything will be deployed in the one server only, VM or
Same.
instance, right? But nowadays, so we can use a we can create the container, something like
For WhatsApp, status
yeah,
one or
status one
message one.
container, chat one container, and messages one container, right? So, so monolithic architecture application means everything will be a part of one project. So monolithic applications are very difficult to maintain. So very difficult to maintain. Microservices, the whole functionality of the application, the whole functionality of the application divided into several sub projects. So which are easily to maintainable. A set of APIs will be available and every API is one application. So every API will one container. So for example, guys, for example, for example, Amazon.in. So Amazon.in, right? First you need to select the items. Then you can add to the cart. So right. So for example, so this is the Fire Stick. I searched this Fire Stick and I added to the cart. So this is this one microservices added to cart is the second microservices. The third microservice is nothing but a proceed to buy. Right. So this is the process to buy. You can select the everything and you can buy that product. Right, guys? Buy that product. So these all are the different microservices are different. Microservices are at added. So every API application is every so API is one application. So every API will one container. Every API will one container. Example, MakeMyTrip is implemented in microservice architecture. So what is that, guys? So MakeMyTrip website. MakeMyTrip website is implemented in microservices architecture. Flights in one API, trains in one API,
Yes.
buses in one API. So in the real time, all are using microservices. So monolithic application means monolithic architecture application. It's a one Docker container. So everything will be in one Docker container. And the microservice based application. So product API, one Docker container, cart API, one Docker container, payment API, one Docker container, tracking, so one Docker container. So everything will be deployed on the different APIs and different containers. So this is nothing but a microservices based application. So if you are deploying your application as a container, the microservice based, so as a container, this is a micro-based service container, and everything will be deployed in one container is nothing but a monolithic architecture. Guys, now you understood? So microservice based application. For example, you see metrics, flights, hotels, homestays, holiday packages, trains, buses, cabs, 4x. So 4x is one container, it is running in, cabs are running in one container, buses are running in one container, the API, trains API is running in one container, holiday package is running one container, homestays is running one container, hotels are running in one container, and flights are running in one container. One container. Guys, now you understood? So what are the difference between monolithic and microservice based application?
Yes, sir.
Yes, right? Yeah. So Docker Compose in the real world applications are getting developed using the microservices architecture. In the real world applications are getting developed using the microservices architecture. In microservices architecture, every APIs will be available. So every API is a project and it should be run as a container. So running multiple containers manually for all the APIs is difficult job. Yes or no? So running multiple container manually for all the APIs is difficult job. So note, to solve this problem, Docker Compose came into the picture. So running multiple container manually for all APIs is difficult job. To solve this problem, Docker Compose came into the picture. So Docker Compose is a tool. Docker Compose is a tool which is used to manage multi-container based applications, which is managed. So Docker Compose is a tool which is used to manage multi-container based applications. Using Docker Compose, we can define and deploy multi-container based applications. Using Docker Compose, so we can define and deploy a multi-container based applications. Multi-container based applications. So Docker Compose. So we will give input to the Docker Compose using YAML file to run multiple containers. What is that, guys? So we will give input to Docker Compose using YAML file to run multiple containers. Docker Compose YAML file should be have information related to the all the services. All the services. So for example, sample Docker Compose YAML file, docker-compose.yaml. So for things we need to mention the version, services, network, and volumes. So everything will be in one YAML file. Everything will be in the one YAML file. So right, we created the volumes, we attached the volumes, we created the services. So under the version, network, right? So version, services, network, and volumes. Docker Compose file name called as a docker-compose.yaml. Guys, now you understood?
Yes,
So we
sir.
can, yeah. So Docker Compose command, so Docker Compose up, Docker Compose PS, Docker Compose down, Docker Compose images, so Docker Compose image -f, file name up and down. So Docker Compose setup, we need to download the setup from here, and so to the Compose. So Docker Compose -f version. So this is the setup, guys. So I will not do anything in the Docker Compose. You guys, so your own, you guys can search the what is Compose, how you can create the Docker Compose files. Okay, so multiple containers are running. So MySQL database container, WordPress container, Docker Compose through the Docker Compose. So Java web app container, Redis container, MySQL container. Three containers are running in the one Docker Compose file. So MySQL database container, WordPress container, two containers are running in this one Docker Compose, right? So managing multiple containers is difficult. So microservice based application. So something like we need a Redis, we need a Docker container, Docker, right? So we need to attach these, right? So managing multiple containers is difficult, right? So managing so multiple difficult. So we discussed this thing, guys. So the containers, running a containers listing, Docker SAM, right? So difficult, right? That's the reason Docker SAM or a Docker container comes into the picture. Okay. So create a basic image, understand how container Docker work. So from maintainer run cmd name. So right, this is a simple Docker file. We can get it. So right, Docker file from downloading Docker file. So this is the center is Java. So yesterday we already knows right Docker file. Yeah. So I want to maintain these Docker containers is difficult, right? So what is the Docker SAM? Docker. So a Docker company created a solution called as a Docker SAM, and Google is created a Kubernetes. Google is a Kubernetes. So Kubernetes versus Docker. So Kubernetes is nothing but a K8s. Task, app deployment, create a containers, launch app on Kubernetes. Launch app on Kubernetes. Kubernetes easy. Kubernetes is easy. So not get started automatically. Single host nature of your Docker container, right? So what are the disadvantages in the container? Not get started automatically. If Docker container deleted, is it started automatically or not, guys? No. If Docker container is in stopped state, or if Docker container is something like in the shutdown state, if the Docker container is in the in the stopped state, how we can start automatically, guys? So there is no possibility to start automatically. So not get started automatically. Single host nature of a Docker container. Auto healing, there is no capability of auto healing. Auto healing is nothing but if the Docker container is crashed, is it automatically started? No. So is it automatically healing? No. Auto scaling, auto scaling means I already told you, right, in the physical or virtualization. So there is a load balancer. If traffic is extended from 20,000 to 40,000, so it automatically create another instance, and so it will route the traffic to the another instances. So if 40,000 crashes, so it will create another instance, the traffic will route it to the another instances. Same like as a, there is no auto healing. If traffic comes into this pitch, comes into the container is not sustainable. So we need to enable the another container. We need to start automatically another container, the load balancer. It is not possible in the Kubernetes. It will not possible in the Docker. Auto scaling default feature is load balancing. There is no load balancing in the Docker container. So enterprise model. So Docker is a simple platform. It does not support the enterprise level. So when we will deal with a big application, for example, Facebook or WhatsApp, the big applications, right? It will not support the Docker. So it is not it does not support the enterprise level. So there is no load balancing, there is no firewall, auto scaling here, there is no auto scaling, auto healing, API gateway. So what is the solution, guys? So who is solving these problems? These problems solve with Kubernetes. These problems will solve with the Kubernetes, right, guys? Kubernetes solve all these problems. So who is solving these problems? Kubernetes. In general, it's a master node architecture. Cluster is nothing but a group of nodes, master node and worker nodes. So what is that, guys? A master node and so worker node. So nothing but a group of nodes, master node and worker nodes, faulty nodes. Immediately it will create the new node or new pod if something goes wrong. Replication controller, replica set, it will create if the one container is crashes, it automatically, if you set the replica set, um, it automatically create another container by using the replica set. Replica set AML file, replication controller file increases. So heal Kubernetes control and fix the damages. So these all are the advantage. So what is meaning of auto healing? So for example, your container is down. As feature called as a auto healing, it goes down, it automatically start a new container. So what is the auto healing, guys? If it goes down, the automatically start a new container. So roll out a new container, Kubernetes roll out a new pod or container going down. So Kubernetes, so who developed this Kubernetes? Kubernetes developed by the Google. So Borg, it is not an open source tool, even a better solution, enterprise level orchestration platform. So Kubernetes comes from the Borg. So Kubernetes comes from the Borg. So Kubernetes is an orchestration engine. Kubernetes is an open source software. So Kubernetes is used to manage containers of our application. Kubernetes will take care of container deployment, scaling and descaling, and container load balancing. Kubernetes is not a replacement of the Docker. Kubernetes is a replacement of the Docker SAM. What is that, guys? Replacement of the Docker SAM. So Kubernetes is developed by the Google and donated to CNCF in 2014. So who maintained the Kubernetes, guys, now? CNCF, Cloud Native Compute Cloud Formation, Cloud Native Cloud Formation. Okay, CNCF, Cloud Native and Cloud Formation. CNCF means Cloud Native and Computing Foundation. Sorry, guys, Computing a Foundation. So K8 software developed by using the Golang. So Kubernetes version 1.0 is released to market in the year of 2015. In the year of 2015. Guys, understood? The same Docker, SAM, and Kubernetes both are the orchestration Docker container orchestration tool. But but why Kubernetes is popular? So why Kubernetes is popular? So Kubernetes is a replacement for the Docker Swarm because of Docker Swarm having some drawbacks, Kubernetes having some advantages. So no auto scaling, Docker Swarm no auto scaling, good community, easy to start the cluster, limited to the Docker APIs capabilities, does not have a much experience with the production deployments at scale. Kubernetes auto scaling capability is the great active community, difficult to start the cluster. So here easy to start the cluster, but here difficult to start the cluster. Can overcome constraints of a Docker and Docker API deployed at a scale more often among the organizations. More among the organizations. Kubernetes, a file. So Kubernetes file. So Kubernetes official website is something like a kubernetes.io. So the features of the Kubernetes: automated scheduling, self-healing capabilities, automated rollouts and rollbacks, load balancing, service recovery, and storage orchestra. Service recovery and storage orchestra. Kubernetes feature. Kubernetes providing advanced scheduler concept to launch container depends on your requirement. So restarts container that fails, replaces and reschedules containers when the node is die, kills container that it does not respond to your user defined health check, does not advertise them to client until they are ready to serve. If something goes wrong, Kubernetes will roll out the change for you. Advantage of a growing ecosystem of the development solution. So deployment solution. If something goes wrong, Kubernetes will roll back the change for you. Take advantage of a growing ecosystem of a deployment solution. Scale your application up and down with a simple command. Scale your application with a simple command up and down. Simple command with a UI. So it automatically based on the CPU usage, it automatically scale up. In Docker SAM, load balance is manual process where Kubernetes supports the auto scaling. So that's the reason Kubernetes is more popular than Docker SAM. So the architecture of the Kubernetes. So what is the architecture of the Kubernetes? Kubernetes works on a cluster model. In Kubernetes cluster, we will have master and worker nodes. So what is that, guys? Kubernetes works on the cluster model. What is a cluster, guys? A cluster is nothing but a group of nodes. What is cluster, guys? Cluster is nothing but a group of nodes. Cluster is nothing but the group of nodes. So master node, worker node, API server, controller manager, HCD, pods, container, Docker runtime, kubelet, kube proxy, kubectl. Guys, everyone can speak out. So what are the Kubernetes architectures? So we'll have a master
Ma-
nodes and worker
Master
nodes.
node, worker node, API server, controller manager,
Hmm.
etcd,
HCD,
pods,
HCD.
containers, etcd,
Hmm.
pods, containers, Docker
Hmm.
runtime,
Hmm.
kubelet,
Hmm.
kube proxy,
Hmm.
kube ECTL,
kubectl,
kubectl.
kubectl. So right, yeah. So here, so how many terminals you know, guys? You know master node and worker node. You know parts. You don't know part, right? You know containers.
Yes, sir. One.
Yes, yes.
You
We
know
know content.
containers. Yeah. You know Docker runtime. You know Docker runtime. So if you want to run the Docker, definitely we need a Docker service. Docker service is nothing but a Docker runtime. Docker service is nothing but a Docker runtime. So you already knows container and the Docker container and the
Runtime.
Docker runtime on, yeah, on these terminology. So you need to know what is master node, what is worker node, what is API server, what is control server, what is etcd, so what is pods, what is kubelet, what is kubeproxy, and what is kubectl. Right? I want to know these terminologies. Right? So I already told you. Right? So what is that? Guys, so node is nothing but a EC2 instance. Node is nothing but a instance. Yes, understood? Sorry guys. So API server, scheduler, controller, and etcd. So who will manage these containers, guys? So containers will manage these services: API server, scheduler, controller manager, and etcd. Guys, mute yourself. Okay. So API server, scheduler, controller, and etcd. So these services will manage the worker nodes. Worker nodes, pods, and containers. Guys, what is that? Pod. Pod. So this is also a pod. So in the pod, what we having? Containers. Container or containers, right? So now you understood the master node. Now you understood the worker node. So now you understood the API server. I will tell you each and everything. I will tell you. Just remember API server, scheduler, controller manager, and etcd. These all are there in the master node. Okay. In the worker node. So in the worker node, our real world application, our real world application. So real world application like Facebook or WhatsApp or whatever it may be. That Facebook. So Facebook is deployed on these worker nodes. Facebook is deployed on these worker nodes. Guys, now used to. So how we can manage that auto healing, auto scaling, networking, everything, right? Here, if you want to run the Docker containers, right? A Docker container, we need a Docker runtime. Yeah, this is the Docker runtime. And kubelet to kubeproxy. Kubeproxy is related to network thing. Kubeproxy is related to network. So kubelet is the agent. So what is that, guys? Kubelet is a agent. Kubelet is a agent. For example, right, guys, if the agent is running, it will validate, it will check, it will connect to the from here and here. So if the container is running, if the not container is not running, so it will create a automatic another container. If the if it is a auto scaling, it will automatically create the another container, right? This is the Docker runtime. What is this, guys? Docker runtime. In the Docker runtime, if the Docker runtime is running, then only the pods and containers are running. Otherwise, it will not running, right? So kubelet is the agent. Kubelet is the agent. It will check from the it will get the communication between the master node and the worker node. Master node and the worker node. So this is nothing but a Kubernetes architecture. Kubernetes architecture. Guys, now you understood the terminology. I will tell you each and everything. No worries. So now you understood the terminology. What these are.
Confusion was this.
Confusion, huh?
Yes, sir.
Yeah.
So this is the Kubernetes architecture. So this is your application. For example, this is your EC2 instance. You deployed the containers. You deployed the containers here. So what this is? This is, for example, a worker node. Okay. So worker node is nothing but your application is deployed on this node, right? So normal in the Docker container. So who will monitor this? Who will monitor this Docker containers? This is the drawback, right? So we cannot monitor the Docker containers if it is running or not. if it is shutdown state or if it is crashes. For example, your Facebook application is running on this machine, right? On these containers. We cannot figure out if the container is stopped or auto healing. There is no auto healing, auto scaling. So these are the drawbacks in the Docker container, right? So then the solution is called as a Kubernetes. So what Kubernetes is doing? Kubernetes orchestration, it will manage the, so it will manage the Docker's containers. It will manage the Docker containers, right? So if you want to manage the Docker containers, right, we need a few services: API server, scheduler, etcd, and a control manager. What this is? This is a master node. What this is? This entire application is a Kubernetes. Kubernetes K8s cluster. So your Kubernetes cluster, Kubernetes is installed on this. Kubernetes is so installed on this. This is the control plane. So in the control plane, you need to install the API server, controller manager, etcd, and scheduler. What is the use of these? I will tell you, no worries. Now you understood, Avinash? Who will monitor these? Who will monitor or who will operate? So in the single Docker container, so there is no possibility to maintain or orchestrate these Docker containers. So who will this orchestrate? The Kubernetes will orchestrate the containers. So will orchestrate the containers. Now you understood?
Yes, sir. Once again, I will take the class after.
Hmm. Okay, 1 second, guys.